In this part of the lesson, we are going to be factoring by grouping again. However, we're going to use that rule that I had mentioned in part 1, always looking to see if we have descending order, and if we have any factors that are in common, we want to factor those out. So that's the first thing we need to look for. Here, looking at this one, we have 2r squared and then 6r. So far it's in descending order, but over here, see, we have a plus 12 and a negative 4r. So we're going to put it in descending order. We're not going to combine any terms here, because otherwise we wouldn't have the 4 terms. But we are going to put it in descending order and factor out some common factors. So let's take a look at them again. 2, 6, 12, 4. There is a common factor of 2. So let's do this. We're going to do a couple steps in one here. We're going to take out a 2 from each of these terms. And so we want to maintain this as the same answer. So we're going to put that 2 on the outside of a parenthesis and then do some division. So what's left over? Well, we just have an r squared. Here we have a negative 3r. And then over here, I'm going to move this term right here. I'm going to use that commutative property and put it right over here. So I have a negative 2r. And then over here, I'm going to move this term, again, is on the other side, so it's a plus 6. Okay, so typically we would combine these terms, but for right now we're trying to factor by grouping. So we're going to go ahead and now group the first 2 terms and the last 2 terms, treating this as a negative number here. Think of this as like negative 2r plus 6. All right, so going to keep this 2 on the outside. We don't really do anything except bring it down from this point. And so now we're going to go ahead and take out the common factors here between all these terms. And so when we do that, I see that r goes into each of these terms. No common coefficient though, because this is 3 and this is 1. Over here, well, I want to make this term positive. So I'm going to make this let's go ahead and take out a negative 2 from each of these terms. And let's go ahead and see what happens. So as we do this, we're bringing this 2 down. This just gets brought down, and we'll keep it in parentheses. So we've got a big set of parentheses here. We're going to put this r on the outside, and inside the parentheses is what's left over when we do the reducing. So let's go ahead and do that. We take out this r and one of the r's here, and we're left just with one r. Over here, well, this r will cancel out this r. We're left with a negative 3. And so we can go ahead and close that parenthesis. And then do the same thing with this one. See, we took out a negative 2. And we'll go ahead and do some reducing. So the negative 2 cancel out this negative 2. We're just left with an r. Well, this negative 2 goes into positive 6 negative 3 times. So minus 3. So you notice that we have the same variable this time. So we have the same binomial. We can go ahead and take out that common binomial. Again, this 2 just gets brought down with the problem. So bring it down. And what do we have left? Well, we still have that 2. But now we have that common factor of r minus 3 that we're going to be taking out. And so we go ahead and put that r minus 3 in parentheses. Again, this 2 is just kind of on the outside here. And so I'll put that r minus 3 right here. And we go ahead and cross off what's left over and see what we have. We've got an r. And then we go ahead and cross off these r minus 3's. What do we have? A minus 2. And there's our answer. So again, once you factor out that common factor, if you've got it, it just gets brought down. Just don't forget about it. And in this case, we had an r minus 3 as the common binomial, so we put that on the outside, and r minus 2. And that would be our answer. Let's take a look at the next one here. Here we look at these, and we have 14, we've got 21, so those have factors of 7 and 2. Here we have 7 and 3. Here we have 3, and here we have 2. So we don't have a common factor between all of them, because 2 doesn't go into 21, and we don't have a 7 in the 6 or the 4. So no common factors, but we can do some switching around of terms. We can use the commutative property, and that's what I'm going to do here. I'm going to take out this term here. I'm going to move it over here eventually. But as we do that, let's do another step at the same time. Let's go ahead and group these terms. And so we didn't see the common factor, so let's go ahead and rewrite it real quick. 14q squared minus 21q, and we've got a minus 4q and a plus 6. So now we can go ahead and group the first two and the last two terms. Again, you're treating this as like a negative 4q. And we can go ahead and take out the common factors between these terms. So we see that we've got a common factor here of 7q. Here we have 7q as well. Over on this side, well, we just have a negative 2. Again, we always want this term positive, that first leading term positive. So let's just take out a negative 2. And so we go ahead and do that work. Let's see what's left over. So we've got that 7q on the outside, and we do some reducing, and we go ahead and take out the 7's, and we have 2 left over. Here we take out a q, and we have 1q left over, so we have just 2q. Over here, this 7 will cancel out this 21, leaving us with 3, so minus 3. And how many q's? Well, this q cancels out that q, so no more q's left over. Well, on the other side, what's left over? Well, we have this negative 2, and we go ahead and do some reducing. This negative 2 goes into negative 4 2 times, so we have 2q. And over here, this negative 2 goes into 6, negative 3 times, so we got negative 3. So now we're back to a problem that we can go ahead and factor further by taking out that common factor of 2q minus 3. That's all we have in common. So 2q minus 3, take that out and take out that other 2q minus 3. And so we go ahead and do that work, and we've got that 2q minus 3. That's what got factored out. That goes on the outside of a parenthesis, and we do that reducing of the 2q's minus 3's, and we see what's left over. Well, we've got that 7q, and we have the negative 2. And that's our answer. So that's what makes these problems a little bit tougher, is that if they're not in that descending order, you've got to put them in that descending order first and look for the common factors. Well, same sort of thing on this problem here. We've got to put it in that descending order. So let's take this negative 2a and put it right over here. So we'll put it in that descending order first, and let's rewrite our problem. We've got a to the third, a positive 4a squared, a negative 2a, and a negative 8. And so we can go ahead and group those terms, group the first two terms and the last two terms, and see what we get. So we go ahead and do that, and we take out the common factors between each of these terms. So here we've got an a squared. That's the common factor between these two. Here we have, again, you want this term positive because I've always made my first terms positive. That's why I was always able to get the same factors each time, and the same binomials. So I'm going to take out a negative 2, and we go ahead and do that reducing, see what's left over. So again, you've got the a squared, but what's left inside? Well, what we do is we take out the factors and see. So we take out 2a's, we're left with 1a, so just a. Here we take out the a squareds, and we're just left with a positive 4. So let's do the same thing on the next one. Let's take out that negative 2 like we did, and see what's left over once we do that reducing. Well, this negative 2a will cancel out this negative 2a, so we're just left with an a. Over here, this negative 2 will go into negative 8 positive 4 times, so plus 4. You see, every time I'm able to get these the same, just because I know they work out, but also I ended up taking out the negative 2 here. And so whenever I have my leading term is negative, I try to take out that negative so that I have the leading term always positive to see if they're the same. So now we can go ahead and solve. We go ahead and take out that common factor between these two terms, which is the binomial, the a plus 4. And so we're putting that a plus 4 on the outside of a parenthesis and seeing what's left over. See, these a plus 4's are going to cancel. We're left with an a squared. And that a plus 4 should be in parentheses, so I'll put it there. And then we took out these a plus 4's and see what's left over. It's the negative 2. And there's our answer. It's as far as we take it. Well, one more problem to try, And this one here, we have some common factors, and we have to put in descending order as well. So let's put it in that descending order, and then also take out that common factor. So we're going to take out that common factor of 2, it looks like. They're all even numbers. Not x, because the 30 doesn't have an x. Well, we go ahead and do that. So I'm going to put the 2 on the outside of a parenthesis, big parentheses here, to show that the 2 is being multiplied by these values. And what's left? Well, I got a 4x to the third. I got a negative 12x squared. Over here, I put the 20x first, so it's a positive 20x. Well, actually, not 20 anymore. Oh, I forgot to divide by the 2. So it's moving a little too quickly, so let's go ahead and fix that right now. So again, I divided by 2 here. Let's go back to this part. Divide 2 into 12, it goes 6 times. Divide 2 into 20 goes 10 times, 10x. 2 into negative 15, or negative 30, goes negative 15 times. All right, well, let's go ahead and now group the terms. Group the first 2 and the last 2 to see if we can take out any common factors. And sure enough, we can. See, they both have factors of 2. And this is already positive, so I don't need to take out a negative. But we also have an x squared for the first 2 terms. Over here, well, this is already positive, so no need to take out a negative. But I see a 5 goes into each of these. Let's see what's left over when we do this. So we go ahead and rewrite what we've got. We've got a 2. Now, since it's being multiplied, I want to put the big parentheses around. We've got the 2x squared. And let's see what's left over when we do that reducing. So 2 goes into the 4 2 times. So we take out that 2. This x squared will take out one of the x, or 2 of the x's from up top. So we're left with an x. Well, this 2 will go into negative 6 3 times, so negative 3. The x squareds cancel out, so we're just left with a minus 3. Over on this side, we still have that 5 on the outside of a parenthesis. It's positive 5, so we'll put that there. And let's see what's left over when we do the reducing by 5. 5 goes into 10 2 times, so we got 2x. 5 goes into the negative 15, negative 3 times, so minus 3. So we're just about done with this problem. We just need to look at it and take out the common factors between these 2 binomials here. Again, that 2 just kind of gets brought down. Put that 2 down here, and we'll take out the common factor of 2x minus 3. Here we have another 2x minus 3. And so when we take that out, you're going to put it on the outside of a parenthesis, 2x minus 3. And then you do the reducing and see what's left over. So these 2x minus 3's cancel out, leaving us with a 2x squared. So in parentheses, put 2x squared. These 2x minus 3's cancel out, leaving us with a positive 5. So put in that plus 5. And there's the answer, right there. So we just bring down that common factor when you've got it, and then just make sure things are in descending order. That's why that was always important. And then from there, we go ahead and take out the common factor. We group them first, take out the common factors. And if we have a common binomial, we're able to take that factor out as well. Well, those are problems involving factoring 4-term polynomials. Good luck on tonight's homework.